Hello, my name is Michael Driscoll, and in this tutorial, you will be learning about loops. So, there are many times when you're writing code and you need to find a way to iterate over something. Perhaps you'll need to iterate over the letters in a string or the objects in a list. The process of iterating over something is done using a loop. A loop is a programming construct that allows you to iterate over chunks. These chunks could be the letters in a string, or the lines of a file, or items in a list. In Python, there are two types of loop constructs, the for loop and the while loop. Let's learn how to create a for loop. The for loop is the most popular looping construct in Python. You can create a for loop by using for x in your iterable, like a string. When inside of your loop, you will do something with each item that you loop over. Now this code above doesn't do anything, so let's write a for loop that iterates over a list, one item at a time. Here we have a list with 3 items in it. For each item in the list, you print out the item. So if we run this code, you can see that it prints out 1, 2, and 3. In this code, you create a list with 3 integers in it. Next, you create the for loop that says, for each item in my list, print out the item. Of course, most of the time, you will actually want to do something to the item. For example, you might want to double it. So here, we take the same list that we had before, we loop over it, and then we print item times 2 using Python's f strings. This time, we get 2, 4, and 6. Or, another thing you might do while iterating, you might want to print out only the even numbered items. So let's loop over this list, and we'll use Python's modulus operator, the %, to check and see if when you divide the item by 0, does it have by 2, does it have a remainder? If it has a remainder, it'll equal 1. If it doesn't have a remainder, it's even, which means that it's, well, return to 0. So if we run this, it should only print 2 as even. Let's go ahead and add a couple more numbers to this and rerun it. So here you can see that 2, 4, and 6 are even, so it is working correctly. As I said, the modulus operator % is used to find the remainder of the item divided by 2. You can use loops and conditionals and any other Python construct to create complex pieces of code that are only limited by your imagination. Let's learn what else you can do with a loop. You can loop over a string. One difference in the for loop in Python versus other programming languages is that you can iterate over any sequence. That makes you be able to loop over different kinds of data types, which isn't always possible in other languages. So for example, you might have a string and you want to loop over each letter in the string. So for letter in my string, print out each letter, which is what happens here. You can loop over a dictionary. When you loop over a dictionary, you will be looping over its keys. So let's say you have a dictionary like this. The first part is the key, so these are all keys. The second part is the value. So if we loop over this dictionary, we should get the usernames, Driscoll, Guido, and Steve. So here, in this example, you specify that you want to extract the user and the password in each iteration. Oops, this next example that I'm going to do. If you have seen my dictionary tutorial, you'll know that items returns a view that is formatted like a list of tuples. Because of that, you can extract each key value pair. So, I don't seem to have that example on here. Let's go back. We'll just do that. Dot items. And we need to fix this code. All right, so here we add dot items. Now when we loop through it, it prints out the tuple-based version, which is the username and the password for each. So, extracting multiple values in a tuple while looping. This is something that is sometimes done when you want to loop. You'll want to loop over the list of tuples and get each item within the tuple. It sounds kind of weird, but you'll find that it's fairly common. So in this case, you want to loop over each item within it. So you say number and fruit in list of tuples, and it will extract it. Now if we try to do something silly like extra here, it would expect the tuple to have 3 items in it, and it only has 2. So if we run this code, you'll get a value error that says not enough values to unpack. That's because we tried to extract 3 items from a tuple that only contains 2 items. So just make sure that when you do loop over tuples that you're extracting the correct number of items, or you'll end up having a bad time. So here, if you try to do 4 item in list of tuples, which is probably what you probably expected me to do in the previous example, when you run it, you just extract each tuple. You don't extract the items in the within the tuple itself. This might work for you too, depending on what your use case is. Python also has the enumerate function that is built into Python. This function takes in an iterator or sequence, like a string or list, and returns a tuple in the form of position and item. This allows you to know the position of the item in the sequence easily while looping over the sequence. Let's take a look at an example. So if we wanted to print out the position of each letter within the string, you could do this: for position, comma, letter, and enumerate my iterable, in this case a string. So when you run this code, it will print out the location of each letter within the string. 0 is A, 1 is B, 2 is C. Always remember that strings start at the number 0. Most things in Python do, as a matter of fact. Alright, now we're ready to move on to the while loop. Python's, of course, other looping construct is the while loop. It is created using the keyword while and followed by an expression. Let's take a look. So here we have a count. It starts at 0. While count is less than 10, print the count and increment the count by using plus equals 1. Whenever you create a while loop, make sure that it has a way to reach an end of the expression. Otherwise, the while loop will run forever. In this case, you tell Python that you want to loop as long as the count is less than 10. If you forget to increment the count, the loop would run until you stop or terminate the Python process. You can create an infinite loop by making that mistake, or you could do something silly like this. While true, print program running. I don't recommend running this code right now because it'll make my presentation crash, because it'll just print forever. If we went back here and just said print count, so like while count is less than, 10 million or something, this thing would run for a very long time. So you just have to be careful when you construct your while loop that you don't accidentally make it run too long or forever. Let's learn how to break out of a loop. Sometimes you just need to stop the loop early. For example, you might want to loop until you find something specific in the iterable. A good use case would be looping over the lines in a text file and stopping when you find the first occurrence of a particular string. To stop a loop early, you can use the keyword break. So here we're going to loop again like we did before, but this time we're going to check and see if the count equals 4, we will break early by using the break statement. So if we run here, we go 0, 1, 2, 3. We reach 4 and we print out that the count equals 4, and then we break out of the loop. So instead of getting 5, 6, 7, 8, and 9 like we did in the previous case, we stop early. You can also use break in a for loop. So let's say we have our list of tuples again. This time we're going to check if the fruit equals apple, apple is found, and we'll break out early. So if we run this, it'll print out 1 banana, then it'll say apple is found, and we never get to the pear. For this example, you break out when you get to the apple. When you use break, the loop will only break out of the innermost loop. So we're actually going to learn about that here in a second, because you can nest loops. So just keep in mind that if we had a nested loop here, the break statement would only break out of the innermost loop, not break out of the entire loop construct. You can use break to help control the flow of the program. In fact, conditional statements, along with break, are known as flow control statements. Speaking of flow control statements, continue is another one. It is used for continuing to the next iteration in the loop. You can use continue to skip over something. So let's say we want to loop over the range 2 through 12, but we want to skip even numbers. If we do this, we check to see if the number is even. If it is even, we continue, which means skip it. Otherwise, we print the number. So starting at 2, we skip 2, print 3, skip 4, print 5, etc. So like I said, if the remainder is 0, it's an even number, and then we skip over it. This lets you print out only odd ones. You can use clever conditional statements to skip over any number of things in a sequence by using the continue statement. Alright, a little known fact about Python loops is that you can add an else statement to them, like you do with an if-else statement. The else statement only gets executed when no break statement occurs. Another way to look at it is that the else statement only executes if the loop completes successfully. The primary use case for the else statement in a loop is for searching for an item in a sequence. You would use the else statement to raise an exception if the item was not found. Let's look at a quick example. So here we have a list 1, 2, 3. If number equals 4, we break out of the loop. Otherwise, else, we print it wasn't found. If we run this code, you can see that we looped through the list successfully, but we didn't find the item we were looking for, so the else statement happened. Let's try adding a 4 to the list, and then let's rerun the code. So we have a 4, let's rerun it. This time we found number 4, and the else statement didn't execute, because we actually found what we were looking for, and it broke out of the loop. Alright, now we're at nesting loops. Loops can be nested inside of each other. There are many reasons to nest loops. One of the most common reasons is to unravel a nested data structure, like a dictionary that contains other dictionaries, or a list of lists. In this case, we'll use a list of lists. So this list has other lists inside of it. So we're going to loop over a list, print the list out, and then loop over each item within the list. If we run this code, you can see that the list is Mike and 12, then you print out the items, then we get the next list and print out the items, etc. This type of code is especially useful when the nested lists are of varying lengths. You may need to do extra processing on the lists that have extra data, or not enough data in them, for example. Let's just go back real quick. I just want to show you what happens. So let's say we add 200 to this one, then we rerun the code. You'll see that this code still works perfectly, and this time we print out 3 items instead of 2. Alright. If you have any questions, feel free to drop them in the comments. Otherwise, I will see you next time. Thanks for watching.